So we're going to do single pile NIM, and it's one of my favorite games to play. Done a lot of work on it. There's a lot of variations. So if you look up the history, if this is something that interests you, there's a lot of history, a lot of interest. At the national math meetings, we always get a number of talks or presentations or papers that have been written about NIM. So I'm going to show you the rules of the game, and we're going to get started playing it, and that's going to run us right out of time today. But on Thursday, I'm going to give you some machinery and have you come up with mathematical conjectures related to NIM, because it's easy to do. So here's the rules of the game. You're given a pile of tokens. So here I have counted 17 tokens. 17 tokens sitting in a pile. And you're also given a subtraction set. These are the number of tokens you're allowed to remove at one time from this pile of tokens. So I'm just going to put 1, 2 here. So that means that both players, 2 players are playing, can remove either 1 or 2 at a time of tokens on their turn. The subtraction set tells a player how many tokens they can take at a time. In this case, they can take 1 or 2. Each player takes turns removing tokens until a player can no longer move. In the case that I have here, you're going to end up with no tokens. You're not going to end up with something there. But I'm going to have you play today and see that that's not always the case. So I'm just going to run through a non-educational version of the game. So here's player 1. Player 1's going to, they can remove 1 or 2. They're like, I'm going to chop this set of tokens down. I'm going to remove 2. So 2 are gone. Player 2 plays and says, I'm going to remove 2 also. So 2 are gone. Player 1 removes, and then this time I'm just going to remove 1. They can remove 1 or 2. So they could have chosen to remove 2 or chosen to remove 1. They chose to remove 1. Player 2 moves, and I'm still going to cut the pile down. So he moves 2. Player 1, I'm going to help you out with that. Remove 2. And on they go. And so I just made up these random players removing 1 or 2 at a time. And if they keep going with this random lost, we back player 1 into a corner with 3 left. I already know what's going to happen. Because if player 1 removes 1, what's player 2 going to do? Remove 2. And then the player 2 made the last move, so player 1 loses. Or if player 2 removes 2, player 1's in trouble. So player 2 will win anyways here. So this is what we call backward induction. With 3 tokens there, I can tell you from that place that player 1 will always lose no matter what they do under this subtraction set. So that's where we're going to head to. I would like you to try to play NIM with 1 and 2 and 17 tokens like I did just now. You can just make 17 dots and play with your partner. If you, I think do we have an even number? 2, 4, 6, 8, 10, 12. So do you mind, David, do you have someone in a group to, let me see, did I count right? 2? I think 1 person has to join a group of 3.
Is there an online version?
I couldn't find, I found a Java one, but the Java securities were not up, so it was, I found it annoying. You can bring it up if you want to, but